Uh, what's the origin of Pascavis, Katie?
It's Polish.
Good morning, folks. If you're just joining us, thank you for joining us. We're going to give others maybe another 2 minutes or so to join, and then we're going to start our morning scoop. All right, I think we are going to start. Good morning, everybody, and welcome to the Arizona Capital Times Morning Scoop. My name is Luigi Del Puerto. I'm the associate publisher and editor of the Arizona Capital Times. We have a really unique morning scoop today. Our guests this morning include outstanding students from ASU and the executive director of the Luminosity Lab at the university. They have embarked on groundbreaking projects and pursued innovative ideas such as a smart DC microgrid that improves access to stable energy, an autonomous drone system that facilitates safety escort in rapid response services in emergency situations, and a system to explore what everybody would call the dark side of the moon. Most recently, they developed the face mask design that ultimately won the X Prize Next Gen Mask Challenge, which we will talk about in a little bit. But first, I want to thank our sponsor this morning. Today's Morning Scoop is sponsored by Arizona State University under the leadership of President Michael Crow, who began serving in 2002. ASU has pioneered the way forward to building a new American university, one built not on the traditional model for universities established in the 1700s, but a model built for today and for the future. Higher education that puts the student first, that is flexible and adaptive, a university that is embedded in the community, that reflects the diversity of the state of Arizona, and that engages globally. In order to stay on that course, ASU operates based on a charter that was developed in 2014. Allow me to share it with you. ASU is a comprehensive public research university measured not by whom it excludes, but by whom it includes and how they succeed, advancing research and discovery of public value, and assuming fundamental responsibility for the economic, social, cultural, and overall health of the communities it serves. Again, thank you, Arizona State University. As I mentioned, we have a great panel this morning. I'm really excited to introduce them. Joining us is Mark Knopfel, who leads an interdisciplinary lab of exceptional students called the Luminosity Lab within ASU's Knowledge Enterprise. It is an applied research and development lab that aims to positively affect society through the use of emerging technologies. Previously, Knopfel drove strategy and data initiatives for companies both locally and in Silicon Valley, working on companies such as Systems, the Wolf Company, and the Arizona Chamber of Commerce. He has received a bachelor's degree in finance, master's degrees in both business analytics and systems engineering, and a doctorate degree in human systems engineering from Arizona State University. As an undergraduate, he served as student body president and was later appointed by the governor to serve a 2-year term on the Arizona Board of Regents as the student regent. Mark, thank you for joining us.
Thank you.
Also joining us is Katie Pascavis. Katie is a sophomore studying mechanical engineering and global health at Arizona State University. She joined the lab during her first month of college and considers the lab integral to her college experience. As a student researcher, Katie has designed COVID-19 sterilization systems, leads the Girl Scouts robotics and Munch Mask COVID-19 prevention teams, helped with the PPE and personal protective equipment response network, and is a member of the grand prize team for the International X Prize Next Gen Mask Challenge. As part of the lab's COVID-19 response projects, she has also worked with the UI Medical School, or rather University of Arizona Medical School students and doctors from Banner Health Hospital on identifying N95 alternatives and mitigating aerosolized particles during procedures. Outside of the lab, Katie is a co-team leader for the Engineers Without Borders and has researched water purification and smart agriculture technology. She aspires to become a humanitarian engineer focused on increasing global access to clean water, food security, and sanitation. Katie, thank you for joining us.
Thank you.
Also joining us is John Patterson, who is a second-year master's degree student studying power systems engineering at ASU. John has been working with Luminosity since 2017, overseeing and contributing to a wide range of projects. John's research topics include public safety drone technology, which we will talk about, energy harvesting technology, educational robotics, industrial waste processing, electric power management, PPE sterilization, and PPE design. His primary research focus has been Project Grid-Base, an energy microgrid research initiative aimed at improving energy security worldwide through the use of advanced power control strategies. That also includes battery energy storage and novel power electronics design. As I mentioned earlier, in the summer of 2020, John helped design and construct 2 PPE sterilization systems in an effort to fight COVID-19, comprising a vaporized hydrogen peroxide-based system and an ozone-based system. John, thank you for joining us.
Thank you.
And finally, joining us is Nick Dave. Nick Dave. Did I get that right, Nick? Perfect. Nick was appointed to the Arizona Board of Regents by the governor on July 17, 2020. He's a member of the Research and Health Sciences Committee and the Audit Committee. He was born to 2 immigrant parents in Chandler, Arizona, and attended Horizon Honors High School in Phoenix. He began his time at ASU at the age of 14, studying Alzheimer's disease in the Biodesign Institute. After co-authoring 2 publications and presenting his research at several conferences as a high school student, he was named to Arizona's 18 Under 18 and awarded the Flynn Scholarship to continue his education at ASU, where he studies neuroscience and innovation in society, graduating with a bachelor's degree in 3 years and completing his master's degree during his 4th year. Dave has worked at ASU's Luminosity Lab for the past 3 years, leading 9 projects, producing 2 patents, and authoring 2 preprint scientific articles. He has also worked with several corporate and government partners across the state, including Phoenix Children's Hospital and Luke Air Force. Nick, thank you for joining us this morning.
Thank you so much for having me.
I guess I'm gonna go to, let me step back up for a moment. I wanna ask Nick, Katie, and John about your experience transitioning from an in-person education to remote learning or hybrid learning. I guess I'll start with Katie.
Yeah, I think for me, of course, there's the goods and the bad, and I really appreciate everything that Arizona State University has done to still encourage us participating. And I think Luminosity Lab is a great example of that, because I've gotten to take on even more projects since we have been in this virtual setting than I was before. Getting to help with the COVID-19 pandemic really brought me farther into the lab. And during this time, like it feels like a family, getting to every day hop on calls with Nick, with John, with Mark. And that really helps with the transition to a more virtual setting.
So that allowed you to actually take on more projects.
Yeah, because you don't have to walk between classes. That time can now be spent going on projects, and it's a weird transition that you don't think about. But yeah, exactly.
What about John? How was the transition for you?
Well, it was actually pretty interesting because what it came down to was effectively switching all of my classwork from mainly going in person to classrooms into more of an online live ASU sync setting where classes were administered over Zoom, still live, but via video. So it was actually not a huge like academic transition for me. It was a very smooth transition going to Zoom. I didn't really have too much difficulty keeping up with classwork and with other, independent research for my master's program. But like Katie said, it really opened up kind of an interesting opportunity for me to expand my scope of work at the lab. I took on a lot of new projects, mostly specifically contributing to COVID-19 mitigation efforts, the PPE response, the sterilization systems and whatnot. But additionally, it really gave me that opportunity to connect more directly with some of my team members via Zoom, where otherwise, one-on-one meeting times might not have even been possible. So it's been both obviously a huge, tragedy that the pandemic has occurred, but simultaneously going to online has actually given me some opportunities to expand my skill set and my network.
I'm very glad to hear that. What about you, Nick?
Absolutely. Just to kind of echo what both Katie and John were saying, of course, with every transition, there comes new challenges as well as new opportunities. And I think that we've gotten a chance to experience that through Zoom. Certainly there were some initial challenges just adjusting to a new lifestyle, but that was something that everyone was going through. Beyond that, however, there's been, like I said, several amazing opportunities to engage on projects like this. Like Katie and John mentioned, the sterilization systems that we produced, the PPE response network that we took part in, and of course, this X Prize competition as well. All of that was done over Zoom. And so to be able to look back at, these last, I want to say 8 months and think that all of this was done virtually, it really, leads me to believe that it wasn't really about whether we were in person or on Zoom. It was really just the group of people we had. And yeah, I think that, while the transition, of course, there's change. I think in the long run, it's something that we'll all look back on and I think we'll remember and appreciate.
Yeah, I always kind of tell people that we're probably more prepared than ever in human history to deal with a pandemic like this one. I mean, we got Zoom and Netflix, and it's like that covers everything that we need, something like that. But Mark, what about for you? How was the transition for you? Given the fact that you run a lab.
Yeah, it was a bit of a surprise, to be honest. We had the spring break for the students where they went off on spring break, and that's when really things started moving remote. And for a lot of us, we were just in the lab and we didn't know that was going to be the last time we had seen each other. And for a lot of us, we haven't seen each other since. And so, I was worried, so much of this lab, as you'll see, it's such a culture-based group. It's the students, they feel like they're a family. So when we had that first meeting after spring break on Zoom, I didn't know what the reaction was going to be. I thought there'd be some students who said, hey, we just want to take some time off. It's kind of a crazy time. But I jumped on that Zoom and everyone was ready to go. Everyone was so excited and they were basically just saying, how can we help? They were throwing out ideas. The special part about that is they essentially told me is like, this is what we were meant to do. The lab exists to impact society. So let's get started. And I think it's been the most productive the lab's ever been in this virtual modality, and which is pretty wild. But I think it's a testament to the students we have. They really rose to the challenge and they've been able to produce some phenomenal work.
Let's talk about the lab. So walk us through the origin story of the lab. What does it do? What does it want to achieve? And I guess, how kind of on a broader scale of things, what does it envision our world would be?
Sure. I can give a little bit of the origin story into how the lab came to be as well. I mean, like you had mentioned, I had gone to ASU for my undergraduate degree, was student body president, was very involved on campus, was on the board of regents as the student regent. And during that time, I had gone 2 technical, degrees. And so I was off to go to Silicon Valley. I had my job all lined up. And I think I was a couple of weeks away from like moving out there when President Crow pulled me aside. And he really thought there was an opportunity. You know, we love this concept of skunk works. And so if anyone on the call isn't familiar with the concept of skunk works, it originates out of Lockheed Martin, came about in like the World War II era. There was this amazing designer of aircraft named Kelly Johnson. And during the war, you need to innovate fast. And so, you know, obviously when you work in a bureaucracy, it's pretty tough to do that. So he basically told the executives of Lockheed that he needed to take the best and brightest, isolate them, and really build this culture of people that would stay up all night and innovating these aircrafts of the future. And over the years, that group has put out some of the most innovative aircraft of all time. And so the idea here was that we would build a skunk works of ASU, and that I would go out and hand select some of our best and brightest students from all academic disciplines and bring them together with some support from the university so that they wouldn't have to pursue grants per se, but they could identify unmet needs in society and then go through the full process of conceptualizing a solution, designing it, developing it, and then finding a way to deploy that solution into society. And so for us, the lab really exists first and foremost to impact society. And we really like to try to focus in areas, you know, such as health, education, energy, sustainability. And it's really fun to see the students really kind of take on these projects that they come up with, that they lead from start to finish. And really that's our vision for, you know, the future. I mean, these universities do such a phenomenal job at training the students for the workforce of tomorrow. And I think, you know, all too often, sometimes we wait for the students to graduate and go off and they take the best jobs in the world. And so the idea is, hey, look, let's leverage their talents now. Let's get them engaged and doing amazing things and impacting society before they leave. And so I think for the students, it's really incredible learning experiences that augments their you know, coursework, actually being able to work on projects, working with students from other disciplines, going through the full project life cycle. And the hope is, you know, all these patents that are now coming out of the lab, all these technologies, the hope is that they would spin out into companies that would reside here in Arizona. And we think it could have a huge economic impact for the state.
So, Nick, how did you apply? How did you become a part of the lab? What was that process like?
Yeah, absolutely. You know, it's actually kind of a funny story. I when I was in high school, I received the Flint Scholarship, allowing me to stay in state, and I was really excited too. I'm born and raised here in Arizona. My parents are immigrants. However, they've actually lived here in Arizona longer than they even lived in India, which was their first home. And so it was a really exciting time for me to get to stay in state. I was originally thinking of going to the University of Arizona. And then a couple weeks before, so I had an idea for some entrepreneurial project I wanted to pursue in high school. And based on the impression that I got early, I thought U of A would be a great place to do this, but ASU seemed like something I wanted to be engaged in, particularly on the entrepreneurship and innovation side, of course. And so I reached out to the former executive vice president of research, I believe, Dr. Ponch, and basically said, hey, look, I'm really interested in pursuing this idea I've got. Could you connect me with someone? And so Dr. Ponch connected me with Mark and a few others, and we actually came together. And this was about 5 days before I was going to make my decision to go to U of A. So we came together, and I kind of pitched the idea, and I got some great feedback from everyone on the panel. And I remember seeing Mark there, and Mark didn't really say too much. And then as we were leaving, he kind of pulled me aside and he said, hey, do you want to go grab coffee real quick? And so I said, you know what, sure. I canceled whatever I had to do next, met with Mark, and over the course of an hour and a half, pretty much changed my mind. And so when I left coffee that day, I knew ASU was where I was going to go. I kind of came into the lab, even actually the summer before I started at U of A, or at ASU. And yeah, I mean, ever since then, I think what really attracted me and drew me to the lab was that it's so unique. You know, it's unique in a private, unique from a private sector standpoint, from a public sector standpoint, from an academic standpoint, in that I felt like I could go in there, go into the lab and pursue any project that I wanted to, just pursue, frankly, what excited me. And, you know, that's something that even if you can do that to some extent, it's very difficult to do entirely what you want to do in a lot of situations. And so when the lab presented that opportunity, I thought there's no reason for me not to. And I, you know, switched my path, came to ASU, and it was hands down, I tell Mark all the time, it was the best decision I've ever made. So
I hope there are U of A alumni that are watching this one. I guess that's for them, Nick, right?
Absolutely.
They're on the call. I didn't try that hard. I really.
So I want to ask John. John, what kinds of questions, let me back up a bit. So what kinds of companies partner with the lab, and what kinds of questions are they bringing to you? And I guess the other question is, how do you figure out which question to pursue?
I think a lot of that comes down to identifying what problems are facing society, what problems the companies in particular are having. I think the prime example I would give for that is the Starbucks handoff plane table that we worked on, in which Starbucks approached our lab saying, we have this situation where people will put, baristas will put cups, coffee cups down on table on the handoff area of the Starbucks, countertop. And people will go up to them and be like, is this my drink? And it'll be kind of unsanitary in some respects because people are like picking up cups and like wiping them on their hands while they're holding them and then putting them back down. So it's kind of a messy process. So Starbucks said, hey, do you guys have any ideas how we might be able to improve this? Very open-ended, see what you can come up with. And some of the most talented engineers I know in the lab and designers and just incredible people came together and developed this system for basically utilizing an LCD display and a basically QR code scanning device, optical scanner, to identify unique IDs for each customer's cup, and then to basically print their name on the table in the LCD using the LCD screen to show whose cup it is and what type of drink it is. And that's a perfect example where we were able to come up with a specific solution to a more general problem that we were pitched by a company looking to solve that problem. And I think Mark right now is bringing up an excellent little demonstration and conceptual rendering of the system in action.
I'll go ahead. I think I have a little video if it plays, just to give the audience an idea of what the system looks like. So there's the drink being delivered, and then you can see the localization of the name. And so it makes it really easy to identify whose cup that is. This has now become a lot more important during the pandemic, as you can imagine. And so this is something, I think it was a month to development, and it's something where we'll build the minimal viable product, and then Starbucks can then go take that to production. And I'll just say, I think over the last 2 years, the lab is now engaged with about, just over 30 corporate partners or, organizations and nonprofits, everywhere from medical groups like Phoenix Children's Hospital to big companies like Starbucks, Adidas, PepsiCo, to local groups like the Greater Phoenix Economic Council, and then kind of like these federal agencies, whether it's NASA or the United States Agency for International Development. And every challenge is a little different. Sometimes we're building physical prototypes like the one you just saw. Sometimes we're building predictive algorithms. Sometimes we're writing software. Sometimes we're designing architecture projects. So our stance is we can really solve any challenge that a business might have. And really they come to us, they have, all of these companies have hundreds of employees that they could leverage. The reason they come to the lab is they're looking for new mindsets, youthful spirit. They don't come to us with an exact playbook of what they want done. They come to us with problem statements. And the idea is that our students can really deal with the ambiguity of that and create a solution that could work and then actually develop a prototype for it.
I want to ask Katie. Katie, walk us through your experience in the sterilization innovation that the lab did, and I guess there was certainly an immediate need, to help not just produce more PPE, but find ways to kind of, in a way, recycle them.
Yeah, absolutely. As Mark mentioned, we all went off to spring break, and then no one really came back to ASU. That was when the pandemic really started to hit Arizona hardest, like at the beginning, and it really became real to a lot of people, especially when we started seeing these shortages all across the country of personal protective equipment. Healthcare personnel were having to turn to reusing their PPE, which wasn't safe, especially if it was contaminated from COVID. And we wanted to do something about the project. Mark kind of like you mentioned that very first call where he pulled us all on Zoom, and we split into different teams to tackle the different issues that are coming up with a main focus on that PPE shortage. The very first thing that happened was creating the PPE Response Network, which is a community-driven response to the PPE problem by encouraging people and connecting people with 3D printers in the community who want to help but just don't know how. They can make the parts. Those parts are delivered to ASU, volunteers at ASU, mostly students, put them together, and then we can get those to hospitals in need. But seeing that that's not something you can't 3D, well, back then you couldn't 3D print a N95. The the N95s were one of the main things running out. So we came up with the idea of sterilization systems. At that time, Battelle had a huge sterilization system that was very big with vaporized hydrogen peroxide, but it was very expensive, thousands upon thousands of dollars, and most hospitals could not get their hands on it, especially the hospitals here in our community in Arizona. So we designed smaller systems with, it actually started with a pressure cooker was the first prototype. And then using hydrogen peroxide that you could just get at your local CVS. And then we expanded to ozone sterilization systems, and really looking at how those systems can help from N95s, and then for ozone also other things like shoes that could carry COVID. And we're really excited that these inexpensive systems can really have an impact during a pandemic.
You say ozone sterilization. For a lot of our audience, we're probably thinking, what does that mean exactly? What is that?
So both ozone and vaporized hydrogen peroxide can eradicate germs, viruses, and bacteria on items. And we were able to validate our systems for a 6-log reduction in a proxy to COVID for SARS-CoV-2, which is just a fancy way of saying medical sterilization, reaching the standards that are required to sterilize items to be used in the medical industry, especially of respirator.
And how much does this system cost? Like if a hospital were to get it, what would it how much would it take them to actually get it set up?
Our VHP systems are a couple $100 up to $600, depending on the parts chosen. And then the ozone system is less than $100, between like $40 and $80, because they're parts that can be locally sourced or sourced easily from online, making it more accessible. Because that was really something we noticed, was accessibility was the biggest issue during this PPE shortage.
Nick, I want to go to you, because if I'm not mistaken, you actually led a project that allowed the lab to win the X Prize. Is that correct?
Yes, that's correct. I
So-
was fortunate to be the team lead.
Yeah. So tell us about the X Prize project, and then how you how you entered your design. Well, and then also how you came up with the design.
Absolutely. So, I think our team was really focused on impacting society from the get-go, from the onset of the pandemic in March, right when we came back from spring break. And so after, we had done this PPE response network, and through the response network, we had delivered over 14,000 units of PPE to clinics in need. And then we created these sterilization systems and had been working to take those to market. This kind of felt like a great next step and just a fun opportunity, something fun to participate in. I think we all just kind of did it because we thought it would be fun. And it certainly was. And so, throughout the competition, we worked with a variety of corporate partners, both given to us from X Prize, as well as corporate partners that existed here in Phoenix, to develop this flow mask, which essentially employs a bifurcated filtration chamber around the idea that if you separate the air that you breathe in from your nose and you separate that from the air that you breathe in through your mouth, you can actually reduce some of the fogging of glasses and some of the main pain points that X Prize gave to us as major pain points that are reasons why people don't wear masks. And so I think, we decided, okay, well, let's give it a shot. We entered in the competition, and we had a great time. We learned a lot, I think, from a lot of the corporate partners that we engaged with throughout the entire process. And of course, we were fortunate enough to win the X Prize, which it still feels surreal, to be completely honest with you. It was, again, a great opportunity, and it was a lot of fun.
And Mark, what was your response? What was your reaction when you learned that you actually won the grand prize?
I think when we signed up for it, I don't think any of us expected, to win. And maybe that was naive of us looking at me. I shouldn't have been surprised at all that they won. But when you have 1,000 entries all over the world, it made me very proud. It was definitely a realization of, what the lab was trying to do. And just to brag about these students, along all these efforts, just the speed at which they were able to innovate. They had mentioned the PPE response network. That was something where in 3 weeks, it came from, hey, we should do this, right? An idea, to designing the platform, the web-based platform, developing it, testing it, and then launching it and having the first users all within a 3-week timeline. And anyone who does software development knows that is a pretty quick sprint to have up and running. And then additionally, they're operationalizing a volunteer service at ASU to actually develop and deliver the PPE. The sterilization systems, what came together in like maybe 2 months. And then the X Prize was a duration of a couple more months. And all of this was in parallel to the other projects these students had, to the classes they had. And so it's really just a testament to them as individuals. I think if anything, people like to think, people who are young, it's like they're in class, they're learning. It's totally not the case. I mean, these students are great examples of that. They are individuals with great talents that can be impacting society today. And so just so proud of, all of their work, from the X Prize to everything they've done around COVID-19.
John, what was the price? What did you get? How much was it?
The prize from the X Prize Foundation?
Yes.
Yeah, so we ended up with a $500,000 prize pot dispersed, or that's going to be dispersed in progress, and it's a huge honor to be able to get that sort of leverage to move forward with designs and do further research. So again, like, huge shout out to X Prize and all of the corporate partners that we got to work with to be able to develop the flow mask design, and then to be able to leverage this this source of funding for all variety of projects.
And Nick, and do you get any a part of that amount? Do you get to pocket some of it?
Our main focus with the dispersal of this funds, once we receive them, is really just to be able to push this mask forward and to make progress with it. Again, our main initiative here was just developing, as it always has been for the lab, it's developing technological solutions and innovative solutions that allow us to impact society. And so I think that's going to be our main focus with this funding as well.
Let me pause here for a second and ask our audience, if you have questions for the students and for Mark, please go ahead and ask your questions. Do it via the Q&A or via the chat room, and we'll try to get to as many of them as we can. Katie, I want to talk to you about the one of the projects that you were leading, the Girl Scouts robotics project. What is it exactly?
Yeah. So right now, especially as a mechanical engineer, only about like 15% of people who receive mechanical engineering degrees are women. It's a huge gap in just the diversity of the field and in the diversity of thought. And a big foundation of that is encouraging girls when they're young to pursue STEM, to find it fun, to enjoy engineering and robotics. So a few years ago, we were approached by Hewlett Packard Enterprise to use something that the lab developed, and actually that John was very fundamental in developing, which is a small, easy to build robot named KIP, which stands for Knowledge is Power, really focused on making it more accessible for people to learn robotics, to make it less scary. And in partnership with HPE and Girl Scouts, we've been developing this into a robotics curriculum. I get to lead an amazing team of brilliant female designers and engineers in developing this curriculum, and we're working on pairing it with KIP to get it out into the country and get it out into the communities in a fun way, an online curriculum that can get girls excited about robotics and get them involved while completing their robotics badges and going farther in the Girl Scouts program.
So the idea really is to encourage girls to pursue, I guess, the sciences is what you're saying. And is this being, do you know if this is being used right now? Are there entities using this curriculum already?
It's still in development. We were about to start our, we've had one robotics camp that Luminosity has put on during the summer, and it was a great success. It was so fun and everyone really enjoyed it. And then we were about to do our second camp right when the pandemic hit. So we're working on developing it, especially in an online capacity, to make it more accessible. And we're hoping that very soon we can start rolling it out.
Nick, I want to go to you. I want to ask you, because your interest is in the biomedical sciences. Tell us about one or two of the projects that you're working on.
Absolutely. So I can give you kind of a gist of a couple projects in this biomedical, the health knowledge space, as we like to call it. So one of the projects that I actually started working on very early in the lab was a project we called Project Syrinx. So Project Syrinx, the whole idea behind it was really how can we improve some of the inefficiencies that exist in the healthcare space, right? One of the things that we went after immediately was some of the issues as far as, you go to a private clinic and you take 20 minutes to check in, you fill out your information, then you go and you take your vitals, and a lot of these processes that could be streamlined using technology. And so what we did was we actually used this process called storyboarding, where essentially we have an as is and a to be model. So we take the perspective of a stakeholder. In this case, a stakeholder would be a patient visiting a clinic. And we actually storyboard out. So we create this comic almost, this comic strip of their experience going through a process. And then that's our as is model. That's the existing version as it exists today. Then what we do is we try and brainstorm how we can improve every pain point in that model to then create our to be model, essentially what we want the future of this situation to look like. And from there, we start designing technology to push us that way. And so that's kind of what Sirix was both, a way of streamlining a lot of the inefficiencies in a healthcare setting, while also allowing us to create an electronic management or electronic health record and a management tool for patients' data, for healthcare data. So that's kind of an example of one project. Another project that
Before you go into that, so I want to flesh it out a little bit because that's really interesting. When you go to the doctor's office, right, they tell you show up at like your appointment's like 9 o'clock in the morning, and they tell you show up like 15 minutes before. So you kind of really show up like maybe 20 minutes before, thinking, by 9 a.m. you would be able to get in, but really you'll get in at some point at 9:30 in the morning, right? So your appointment is at 9, you show up at maybe 8:30, and then you kind of wait for 1 hour. And part of that is called, of course, the paperwork that needs to be done. I know, for example, some clinics have started asking patients to just fill out forms online. And so they kind of cut down on that process. But what are some of the solutions that you're working on that you're finding may actually solve, cut down the wait times?
Absolutely. Yeah. So to give you an example and go back to your question really about the start of your process in the clinic, right? So the idea behind Sirix was this is all done through an app. You input your history, your family, social, personal history, all on an app long before the time comes. But when you get to the clinic, you don't have to check in with anyone because you've already uploaded your driver's license, and the app detects based on your location that you've arrived at the clinic and notifies the clinic and the people who work at the clinic on the back end. And then from there, even to the point of, taking vitals, for example, a lot of these vitals that are taken pretty typically, for example, weight, height, things of that nature, to calculate BMI, even blood pressure. A lot of those can be taken by pretty simple automated machines that exist even in Walgreens today. And so again, having those machines then connected to an app on the back end, the same Sirix app allows you to take those, streamline them into your electronic health record, and be available for your doctor to see, let's say on his iPad from his version of this Sirix app. And one, to kind of touch on, again, this idea of wait times. One of the projects that the lab has also worked on is a project for Phoenix Children's Hospital, actually developing a chatbot that allows people to use this chatbot and communicate with the chatbot to input their family and social history. So again, another way in which, we're trying to improve these inefficiencies, but also, a way in which we're working with corporate sponsored partners to do so.
And John, I want to go to you. What is a DC microgrid? How does it work, or how do you hope it's going to work?
So the systems that we've been developing for the GridBase project are basically aimed at providing offline energy storage for individuals, communities, and sites that may or may not necessarily have access to reliable electric power from their national or larger scale AC power grids. So because energy or electricity is typically stored in batteries, which use DC direct current as what they generate, we actually are building a microgrid around that direct current power source. And all a microgrid is just a connection of generating energy sources and loads that are meshed together in such a way that they can share energy where it's needed. It's a small localized system that can be made in a wide variety of different scales. So what we're doing at GridBase is we're trying to leverage things like secondhand automotive electric vehicle batteries, where you might actually see either wrecked vehicles or vehicles that have been sent for recycling that still have very much usable, long life remaining batteries that happen to also operate in a typical voltage range that's similar to what we need in our microgrids. So we're looking into leveraging secondhand electric vehicle batteries for a sort of modular energy storage solution. And then additionally, because this system is localized and uses DC power, we can also do things like directly incorporate renewable energy into these systems. So directly connected solar panels with maximum power tracking, even things like on-site generators, wind turbines, run-of-the-river turbines, and those sort of energy sources. So to tie all these technologies together, we're using more new cutting-edge technologies in control to actually monitor the power flow from the sources to the loads and prioritize which loads remain operational at which times during an outage event. So we may allow things like critical infrastructure or medical supplies and equipment to operate during at the highest level of priority during a power outage. And to allow those things to operate longer, our system may automatically curtail some of the loads that are less critical. Things like HVAC, that's heating, ventilation, and air conditioning, things like lighting. Some of these loads may be shed before the critical loads are turned off in order to ensure those critical loads can remain powered for as long as possible.
So I guess the question I have for you is that, so this microgrid system that you're working on, the idea then is that just entities, right, buildings perhaps or communities can set up the system, and that would help them, among other things, ensure that they have a reliable power source. Is that the idea?
Exactly. So we're designing the system to be scalable and modular to be able to operate over a wide range of microgrid sizes. So this could be as small as like one person with a battery and an inverter and a solar panel at their house. For example, if you're interested in what our inverter technology looks like, they're about this size, so they're fairly small units. This inverter could power one or more household circuits fairly typically. And you can expand these as large as like entire communities. I mean, you could have hundreds of kilowatts of load connected to megawatt hours worth of battery, so very sizable battery structures, and everything in between. So they're designed to mesh seamlessly with existing AC grid infrastructure, and they're designed to be scalable so that maybe a community puts in one small battery module and one inverter, and then as funding becomes available, they can actually tack on or add on additional batteries and additional inverters as they become available.
And just so we're clear, we're talking about off-grid, right? So this is a system that's off the grid. We're not using the current.
This actually can do both. So the systems are actually designed to operate synergistically with the grid, so they can draw power from both renewable sources and from the grid directly. But in the event that the grid goes down, they can operate fully autonomously without any input from the grid. And additionally, if needed, if you're setting up in a remote location where there is no AC power grid, the systems can completely operate fully from independent energy sources. So renewable energy on site, generators on site, whatever the source may be, the systems can be configured to operate completely off grid if desired.
So this would help, in cases of communities where they might be too far away to put in like new electric lines. This would help them, but this would also help, systems and or entities within the urban center, right? Just sort of a backup, but also as a way perhaps to kind of lower their electric bills.
Absolutely. And in fact, when it's really one of the really cool things we can do is voluntary load shedding from the mains grid. So you may have a system that's tied onto the grid that pulls power from the grid throughout the day. And it may be, one of the things that can actually decrease the occurrence of power outages is to decrease the load that you're placing on the grid at peak hours during the day. So what we can actually do is set up our systems to voluntarily disconnect themselves from the mains grid at the times of the day when power is in highest demand, and then reconnect to charge up during off-peak hours. So that's another grid service that we can actually provide. And especially like commercial customers can potentially see advantages in their billing rates if they can negotiate, peak hours usage.
One of the things that I think the lab is working on is that, a system to explore, as I mentioned earlier, so the dark side of the moon, right? That's kind of the popular, way to call that side of the moon. But Mark, tell us what it is and what do you hope to achieve here?
Yeah, it's actually a competition, a student competition that NASA put out. It's their Big Idea Challenge. And so this one in particular was the biggest challenge they had ever done. They got the most entries they ever had. And the idea was they were soliciting the help of students to develop prototypes and systems that could help explore the permanently shadowed regions of the moon. The idea there are they're craters, and the thought is there's probably, water, frozen ice there, which they'd be interested in analyzing and exploring, because that's how they could create fuel to do future travel. And so they put out this challenge, and our students thought, speaking of moonshots, this would be a great thing to pursue. The idea is that these prototypes would actually go on the Artemis mission. The best one would go. And so we were actually one of 8 universities that were selected as a top finalist, alongside of universities like MIT. And so we were funded to build a prototype, the concept that the students had submitted. And what was cool about this is, a lot of the universities that had won this, they were leveraging work they had already at the institution just to build on that. We were building a system kind of from scratch, and we got awarded, I think, in February, January or February. And so the work started in March with the pandemic. And so what was really cool is we were able to build a full prototype system. The system that they developed was a launcher-based system, spring-loaded, that can send titanium probes into the craters with sensors in them. And then we would launch a probe that with hang time overhead to establish line of sight back to the rover, and to be able to transmit that data. And so we were one of the only teams that was able to actually build that prototype from start to finish during a pandemic environment. And we actually won the most innovative concept for that competition, which was really exciting. So the students will continue to work with NASA to advance that technology. And the hope is that some of this technology might end up on the moon or Mars one day.
That's really cool. I want to go to some of our questions, audience. One of them is how does an ASU student get into the lab? And Mark, I don't know if you want to answer this.
Yeah, I mean, I can, when the lab started, I think the reason I was chosen for is just because I had been at ASU for so many years. I was really involved. I had, a lot of different degrees and a lot of different backgrounds. So when I first started the lab, it was really me reaching out to, kind of the big influencers on campus. I met with a lot of students to try to identify that initial set. We started with 15 students, and now, we're over 50 students that we engage in the lab. And so once the lab was established with that initial group, since then, it's really been the students that help do the recruiting. A lot of the times we'll launch a project, and we have every type of student you can imagine: law students, public policy, psychology, design, etc. But sometimes we'll launch a project, and as part of that chartering and planning process, we identify we need a skill set we don't have. So we'll go out and find a student in a program that has that skill set to come join the lab. A lot of the times it's our students saying, hey, I know someone, I'm in class with them, they're really great. We always have an open enrollment where people can apply for the positions, and we're, constantly reviewing them. But, it's really nice. For me, it's nice that once it was established and the culture was built, it's something that has just grown itself. And I think that's great in terms of scalability, right? The dream is you have a lab like this, it's run by the students do the recruiting, they make those decisions. And it's something that, when I'm no longer there, it can live on forever.
Aside from, of course, the benefit of having this experience and working on really great projects, what else do the students get from being a team member of the lab?
I'll have a student answer that one.
Oh, right. So Nick, go ahead.
Yeah, I can take that. I think there's a couple things. First is, a family in a lot of ways, and a lot of, really close friends, a lot of really close colleagues that at least I can say personally I'll work with for the rest of my life, not just in university. But the second thing is really an opportunity to apply what we learn in the classroom. Apply what we learn in the classroom, and beyond that, just apply the skill sets that we have to actually not only make impact, but in these situations throughout all of these projects. I think more than what we've accomplished, I think the laundry list of things we've learned is maybe threefold that. And so I think it's a great learning experience. But beyond that, again, it allows students to engage in their community immediately. And I think it just goes to highlight the importance of, continued investment in the students and in the state, particularly because not only are these, our students here in Arizona at ASU, at NAU, at U of A, not only are they, important in generating the new workforce in the future for the future of the economy, but beyond that, I mean, they're having impact on the economy and on the state itself right now, every day. And so, continued investment there through, of course, this new economy initiative and the Promise program is, something that, of course, we as students really appreciate, and it continues to allow us to have the opportunities to participate in things like Luminosity, as well as for future students to have the opportunity to do the same thing as well.
I guess when you mentioned about the new economy, of course, we're talking about really what many call the fourth industrial revolution, right? We're talking about AI, robotics, really advanced engineering, the kinds of programs that I think the universities hope would position Arizona as a place that's very vibrant economically, but also really leading in developing and launching like cutting edge technologies. John, I want to ask you, when you're done with your master's degree, what do you hope to do? Like what is the future like for you, or how do you envision your future is?
So actually right now, even beyond what I do in the lab, I work for a biotech firm that builds electrical nerve stimulators for clinical anxiety treatment. And then I also run an independent consulting firm for doing PCB, printed circuit board design, custom power electronics design, and just general product development.
I'm sorry, did you say that you also run a consulting business on the side?
Correct, yes.
While you're studying?
Correct, yes. So I'd actually like to continue working on both of those ventures, the biotech firm and the consulting, but I actually am planning on continuing my work here at the lab, whether it's on a voluntary basis or through like a position or some, effort that I can actually contribute it through. I am actually planning on staying involved even beyond being a student, because it's such an amazing community. Like I've created, I've helped be a part of creating this environment where students can come and build their own ideas physically and design systems that wouldn't necessarily even be possible without all of the talent that we have in these places. So I want to remain involved in that, and then of course I want to synergize that with my other endeavors that I'm working on the side, so that I can continue to develop my own career moving forward.
And I guess if there's somebody from APS or SRP listening in, you might want to contact John and try to secure his, he's working for you at, as soon as possible, something like that. What about you, Katie? What do you hope to get out of this program? But also, you're graduating in what, 2 years, something like that?
Yeah. So I'm still a sophomore, and this program has
I'm
been.
sorry, you say yeah, that's right. You're just a sophomore student.
So I'm planning on going to grad school after this in environmental engineering, but honestly, I'm still not totally sure what I want to do after college. And this has been great because at a lot of other schools, I still wouldn't necessarily be involved in research yet. Versus my very first month at ASU, I came to Mark and I was like, "Hey, can I join the lab? I know I'm only just a freshman." And he was like, "It doesn't matter. Like, age does not matter. Just what matters is what you want to do." So Luminosity has been great for having all these different opportunities, being able to get involved even as a freshman, and even now as a sophomore, when at other universities I wouldn't have that chance. So I can kind of figure out what I want to do after college.
What is your what really is your interest? Like what, if there's such a thing as well, there's no such a thing as a dream job. I can tell you that. That's but if you can kind of create something that maybe gets very close to that, what would that be for you?
I think for me, it'd probably be increasing access to sanitation, clean water, and food security, which has been great through the lab. Unexpectedly, through these COVID-19 projects, we've been working on the ozone and vaporized hydrogen peroxide systems that we were talking about earlier. And I firmly believe going on that those will help increase accessibility to sanitation and even to clean water with ozone possibly. And that by continuing those projects, unexpectedly, I kind of led into what I'm hoping will be a dream job that someday I can pursue. So it really works out just getting to like having a lab like this where you find your passion because it's so open-ended and you get to choose which projects you're going to be on and what you pursue.
And Nick, are you going into politics?
That's a great question. Right now, I'm not entirely sure what I'll do after college. I do know, I think through Luminosity, I've developed a true passion for innovation, for R&D, and for business. And as you mentioned during the intros, on the side, for the last 6 years since I was 14, I've been doing Alzheimer's disease research. I've always had a passion for proteins and these biological little molecules. And so one of the things I told Mark when I first met him was, I spent a lot of time studying one disease, Alzheimer's disease. But, I see this potential impact in my lifetime as, I could spend my whole life focused on one disease, or I could work to create biotechnologies and technologies and even systems really that push us closer to cures in thousands of diseases or in thousands of fields. And so, that's kind of a passion for me and something that I really hope to advance in my career. But beyond that, as you mentioned, I do have a strong interest in higher education, in policy, and most importantly, honestly, in Arizona. And so I hope that I can go ahead and, make a career at the intersection of business and biology and R&D, but then come back to Arizona and continue to give back to the state that's given so much to me. And of course, the higher education system here as well.
And I guess, Mark, right now you're leading this team, which is an awesome group of students, and you're doing groundbreaking work. I'm really excited for you. What does the future hold for you? What do you plan to do in the next 10 years or so, something like that?
Well, for me, I absolutely love what I do. Being able to mentor these students, watch the incredible work they do, set up, a place for them to have these innovations has been great. What I'll be doing next month is becoming a father, which I'm very excited about, and all the students know that, and excited for that chapter of my life. But in terms of the
you're going to be a dad in about a month. So you're right.
March 15th. This is our first child for my wife and I.
Oh, how exciting! Congratulations.
But then with the lab, my hope is, at ASU, we have about, 50 students engaged. I think for creating the culture we want to create, part of this, you have to keep it small just so that we have that family dynamic. But at the same time, we want to see as many people engaged in this type of model as possible. So, ASU being, number one in innovation, having this model, it's something you don't see at other institutions. So I think what we might do is start a consortium housed at ASU and powered by ASU, where we would go and help charter Luminosity labs at institutions around the country and the world. We're already piloting this. We have one in Ghana and a few other coming online. And the idea is we'd create a network of students just like the ones you see here, working collaboratively towards R&D research, and then graduating and becoming part of this network. Like John said, wanting to come back and give back and volunteer. And I imagine that Nick, Katie, and John could potentially be the future of that, where they go off to launch, these labs other places, and it's really be ASU's way of spreading their model of innovation throughout the country.
What you envision is even going beyond ASU, correct? So you're a network of students and a network of labs, which is kind of the model right now in the private world, as well as in the public world. But a network of students, a network of labs that are really looking at day-to-day problems and offering solutions and finding ways in which, so that we can really sort of a altruistic way of saying a better life, right?
Yeah, absolutely. I think ASU is so far ahead of other institutions in terms of what they do in innovation. I think it's surprising to think that a model like this, the student-driven model like Luminosity, doesn't exist. So I think, ASU is going to want to make sure that we get that model out there and really help spread what we've been doing. And I think that engaging these students at this age, not only is it going to change our state with the students in Luminosity, but I think it has the potential to change the world. And we're excited about that.
Mark, John, Katie, and Nick, thank you again for joining us this morning. I wish you all the best. I wish that, at some point you get to see and meet your friends again. I had Dr. Crow here a couple of weeks ago, and he said there's no going back to normal. That's not going to happen. Normal as in what we did before. And I think COVID-19, this pandemic, had merely magnified the problems that we have, but it also afforded us the opportunity to actually fix or start fixing some of those long-term problems, as well as the more immediate ones. So I just want to thank you. I'm really inspired by these students, and Mark, thank you for leading them. I want to thank again the Arizona State University for sponsoring this morning scoop. And to our viewers and our listeners, we'll be posting this video. So if your friends or colleagues missed it, we will post it on our website. Let them know to go watch it and get inspired. Thank you again, and enjoy the rest of your day.
Thank you.
Thank you.
Thank you.